Last type of problem that we are going to see in this chapter is factoring a sum of squares. And before I get into that, I kind of want to backtrack a little bit to one of our factoring strategies that we saw. And if you remember, when we saw something like this, x squared minus 16, this was a difference of squares because I have a perfect square here and a perfect square here. X and then 4. The way that we factored our differences of squares was x plus 4 times x minus 4. And the fact that we had opposite signs here made it so when we multiplied this out, x squared minus 4x plus 4x minus 16, the opposite signs in the middle made it so my middle terms cancel out, giving me the x squared minus 16. Here's where we get into the factoring a sum of squares. Now, if I have 5x squared plus 20, first thing I notice is that both of my terms are divisible by 5. So I'm going to factor out a 5. Then I realize, hey, this x squared plus 4 here, x squared is a perfect square, and 4 is a perfect square, but this is a sum because I have addition in the middle. And until now, we have not been able to factor things like this. Keyword, key phrase, until now. Ignoring the 5 for a second here, the way I can factor a sum of squares is pretty similar to our difference of squares, where I find this is x, this is 2. Here's my trick. When I put the pieces together, I don't just say x plus 2, x minus 2. I write x plus 2i, x minus 2i. And then I'll bring my 5 down. Okay, so this would be my factorization. Let's see, why on earth does this work? So I'm going to take this x plus 2i, x minus 2i, and multiply this back out. So my first terms, x times x is x squared. And then my outside terms would be minus 2ix. And then inside is plus 2ix. 2i times negative 2i is negative 4i squared. So again, the fact that I have opposite signs in the middle here, x plus 2i, x minus 2i, makes it so my middle terms cancel out. I have my x squared. And then right here, negative 4 times I squared. Remember, I squared is negative 1. Negative 4 times negative 1 is positive 4. So having those i's makes it so I can take what would be a difference here, the negative 4, and multiply it by negative 1. So that it works. All right, so my final answer here would be 5 times x plus 2i times x minus 2i. This will come in handy a little bit more as we go, especially into chapter 5.